All right. Good evening, everyone. Am I audible? Listen. Audible?
Yeah, audible.
All right. So, guys, we'll get started with our session today. Where did we stop in our previous session? What happened in last session? Routers, switches, and server. Okay. So, in our previous session, we have seen enterprise level how routers look and how it works, and how switches work, and server. So we have gotten some basic idea about routers, switches, and hubs, servers in enterprise level. So today we'll be getting inside IP addresses. Okay, so we'll be discussing about IP addresses. So let me share my screen. Alright. So guys, today's agenda. So we'll be getting inside our IP addresses subnet masking concept. Okay. So IP addresses and subnet masking will be getting inside this concept. So guys, listen to this very carefully in today's session. So IP addresses are very important concept. So I know people know little bit about what IP addresses are used for, but there are a lot more other things to learn about IP address, which we'll be seeing it on our today's session. So starting off with when it comes to IP addresses, guys, we have different types of IPs. So when it comes to IPs, so we are having public IP, we are having private IP, we are having static IP, and we are also having dynamic IP. So public IP, private IP, static IP, dynamic IP. So we have different types of IP addresses. Okay. So let's see about it. So now, when it comes to static IP address means it's a fixed IP address. Static IP means it's a fixed IP. So where we manually provide IP address to our system. So that's a static IP address. Dynamic IP address means it is a temporary IP address given to us. Dynamic means it's a temporary IP address. That means it can change. It's not fixed. It can change. So that is dynamic IP. By default, all your systems have option called assign or IP address automatically, where router will have DHCP, where it will automatically assign your system with an IP address. You don't have to manually go and change it. So the thing is that is a dynamic IP. So every time your router refreshes or every time you disconnect from Wi-Fi and reconnect back, there are chances that your IP can be different. Okay. So because that's a dynamic IP, it's not a fixed IP. So static IP means it's a fixed IP. Dynamic IP address means it is temporary IP address. It can change. And when it comes to public IP, private IP concept, so we'll get into it. But before getting into it, do you know we have two versions of IP? IPv4 and IPv6. So what is the difference between version 4 and version 6? 32-bit and 128-bit. So what about you guys online?
IP6 is a MAC address.
IPv6 is not MAC. IPv6 is more secure.
Yeah, compared to IPv4, IPv6 is very secure.
All right. Let me give you guys an idea. Let's just pick up some good image. All right. So guys, when it comes to IPv4, if you see, it is deployed in 1981. Okay, it is hexadecimal. Yes, IPv4 is 32-bit, 64. Yeah. Okay. So you can say not 4 bits, you can say 4 bytes. 4 bytes and 8 bytes. 1 byte equal to 8 bits. So that means 4 into 8 is 32 bits. All right. So IPv4 is deployed in 1981 and IPv6 is deployed in 1998. Okay. So 1981 IPv4 and 1998 IPv6 has been deployed. And IPv4 size is 32-bit, whereas IPv6 size is 128-bit. That means almost 4 times the size of IPv4 is IPv6. Okay, it's 128-bit. Actually, it is 64-bit extendable up to 128. But in Google, if you normally search, you'll get 128. But if you do in-depth research, you'll know it is 64-bit extendable up to 128. But either way, let's say it is 128-bit, which is like 4 times the size of IPv4. And the other thing is when it comes to IPv4, it is only decimal. Okay, it's only numeric format. Whereas in IPv6, it is alphanumeric combinations. Alphanumeric combinations. So that means in IPv4 only you'll have numerics, and in IPv6 you have alphanumeric combinations. So in IPv4, you can only create 4.3 billion unique addresses. But in IPv6, you can create 7.9 into 10 power 28. That means trillions of possible addresses you can create. That means almost unlimited IP addresses you can create using IPv6. But IPv4 only 4.3 billion. So now, do we have more than 4.3 billion devices in market across globe? Obviously. We have more than 4.3 billion devices existing in this world. So why are we still using IPv4? If you see, even though IPv6 was deployed in 1998, still we are using IPv4 only more. So what is the reason behind it? Any idea? Why IPv4 we are using? Why not IPv6? Even if you see many ISP providers, so if you go and type what's my IP address, and if I check my own IP, so you are able to see I have IPv4. So when it comes to IPv6, I don't. So if I'm again connected to Airtel or if I'm connected to Jio or so, I'll be getting IPv6 as well. But many providers, they provide IPv4. Many devices, they support IPv4. So why is that? Why can't they go with IPv6? Why can't everyone across globe, why can't they go with IPv6? Any idea? Maybe it depends on security level and requirement.
Maybe it's a reliable and simple IPv4.
IPv4 is reliable and simple. Okay. So guys, the thing is, if you see, when it comes to IPv4, you are able to see the size of it is 32-bit. IPv6 is 128. That means 4 times the size of IPv4. So if you know, every time I send a data, first of all, that data will get divided into small pieces. Each piece will be sent separately to destination. I hope you know this, right? So if you guys know, when you are sending some data, your data will not directly get dumped inside your receiver. So your data will get divided into small parts. Each packet will be sent separately to destination. So every packet we send, our source IP, that means sender IP address, and receiver IP, whoever is receiving it. So sender and receiver IP will be attached with every packet of data we are sending. Are you guys getting it? So just imagine, whatever message you are sending, first of all, that message will get divided into 100 packets, for example. And each packet, there will be your source IP, destination IP. So if you are using IPv4, source IP is 32-bit, destination IP is 32-bit, so which comes across 64-bit total size of IP address. For every packet, 64-bit is the size of IP address. But when it comes to IPv6, so sender IP 128-bit, receiver IP 128, that means 256-bit. So every packet we are sending, 256 bits of data is attached. Just imagine, so the size of the packet increases, the time taken for the packet to reach destination also increases. Are you guys getting this idea? Did you understand? So what is the difficulty with IPv6? The major difficulty is every time we are sending some data, first of all, our data will get divided into small packets, and each packet will be sent separately. And every packet, there is 256 bits of size of IP addresses attached, which is huge. So if I'm using IPv6 for communication, it will be slower. Is it clear? So if I use IPv6 for communication, it will be slower compared to IPv4. Clear, everyone, so far? Got it? IPv4, IPv6. Yes, yes. All right. Now, it's fine. We understood why we are using IPv4 more compared to IPv6. That's okay. But the problem with IPv4 is we have only 4.3 billion unique addresses generated with IPv4. So even though we are using IPv4 more, how are we able to manage it? In entire globe, we have only 4.3 billion possible IPv4. So how are we able to manage it with this many addresses? There are trillions of devices, but only 4.3 billion IP addresses. So how can we manage? Any idea? So each device for communication, we need an IP address. So if every device needs an IP address for communication, so why and how are we able to manage? That is where public and private IP address comes into the picture, guys. Okay, public IP, private IP, this is where it comes into picture. So how public and private IP will change the working process, or how can we manage with only 4.3 billion IPs, entire globe, all the systems will be able to communicate with each other, but only 4.3 billion IP addresses are existing. So how are we able to manage it? So it's because of public and private IP. So what is public and private IP concept? I'll tell you. So already you guys know a little bit about it, but either way, if you see, previously also I explained, if this is our network, okay, home network or office network or whatever network it is, college network or any network. So you are having multiple systems inside your network. You are having multiple systems inside your network. And you have a router. You have a router. Okay. So now you have multiple systems and you have a router. So there will be only one IP address given to entire network, that is public IP. There will be only one IP address assigned to entire network by ISP provider. Inside network, all these systems have a unique identity inside network. So they all have unique names, that is private IPs. Every system has a unique private IP, but all the systems have the same public IP. So we have two IPs, one is public IP and the other is private IP. Public IP is given by internet service provider. Private IP is given by our router itself, or we ourselves can assign our system with an IP address, which we have did earlier. Okay, so in previous session we have done, right? So in Cisco Packet Tracer also, you yourself have opened every system and gave IP address. That's a private IP. So now we need private IPs for communicating privately. That is inside network for communicating, we need private IP. But outside network, I need a public IP for communication. So we have only one public IP. I gave you example, right? So if there is Facebook, if we have Facebook, if one system is sending, system A is sending a request to Facebook. So once from your system till it reaches router, it is private IP. But once your request crosses your router, it's about public IP. Public IP. So if system B also sends the same request to Facebook, so from the system till it reaches router, again private IP. But once it goes out to Facebook, it is same public IP. So for Facebook, both systems which they are getting request, but Facebook will see same IP. So it differentiates each other from sessions. Every browser has a unique session. So that is how every browser you open, it will ask you to log in separately. Okay. So according to Facebook, you are all same. So if system A does any illegal activity on Facebook, and if Facebook blocks the IP address, even system B will get blocked because they all have same IP address outside. That means you are nothing when you go outside. That means you don't have any unique identity outside your network. Yeah. So that is how we are able to manage with one single IP. We are able to manage entire network. Private IPs are reusable. Public IP is assigned only one for network. So even though I have 100 systems in my company, I have only one public IP. Clear, everyone? Got it? Even online, do you understand? Yes. Okay. So guys, now moving forward. So now that we understood, okay, with one single public IP, we are able to manage the entire network. So we understood about private and public IP a little bit. So now, what is the another advantage of having public and private IP? another advantage of having public and private IP. So the another advantage is your system doesn't have a unique identity outside network. So if there is a hacker, hacker is in their own network. So let's say this is a hacker and is in his own network. Now, if hacker wants to hack your system, let's say your system is system A. If hacker wants to hack your system and hacker can get your IP address. Okay, so hacker can get your IP. Let's say hacker has your IP and he wants to hack your system. Is it possible to reach your system using your IP? Because this is not your own IP, it is a public IP. Okay, so if hacker has your IP address, he can't directly reach out to your system because this IP doesn't belong to only your system. It belongs to everyone. So he cannot target any system using a public IP. So the thing is, because of this public and private IP concept, since you are not reachable outside network, hackers cannot directly hack your system. Okay, so what hackers will do? Hacker is going to create some malicious applications, crack the softwares. Okay, and in that softwares, they'll attach their IP address, hacker's IP. So when you install those softwares, or when you click on links which hacker sends, so what happens? You, from your system, how a connection is going to Facebook? Similarly, from your system, a connection request will go to hacker. Okay. So from your system, how you are able to reach out to Facebook in similar fashion, from your system, a connection request will go to hacker's IP. So once hacker gets connection request from your system, so using this connection, he'll be able to send commands and control your system. Okay, once hacker captures your connection request, so using that connection request, he can send commands and control your system. Now, the question is, Facebook means it's a server, you are able to reach out to Facebook. But when it comes to hacker is also having a normal laptop. It doesn't mean that hacker maintains server. So they are also having a normal laptop. If hacker is not able to reach out to your IP, how are you able to reach out to hacker's IP? Are you guys getting my question? So my question is, I told you that hacker cannot reach out to your IP because you are not having a unique identity outside network. But how can you reach out to hacker's IP address? How is it possible? Any idea, guys? Dinesh, Sumansu, Nitya, Venkatas, Shravan. No idea. No. How can you reach out to Facebook? Facebook is also like a normal server. Server means like a normal system only. How are you able to reach out to Facebook or any other web server? How are you able to? You open browser and you type facebook.com or google.com. You are able to access the content. So the content is getting loaded from that particular servers on the Facebook or Google and all. So ultimately, you're sending a request from your laptop, from your browser to Facebook. Facebook is responding back. How are you able to send a request to Facebook? DNS. Internet. How internet? Okay, internet is okay. Via internet you are sending. So if your system is not having an identity where others can reach out to you directly, even Facebook is also inside Facebook network. Facebook server is also inside Facebook. How is your request reaching Facebook server? So I'll give you guys an idea. So the public IP which you guys are having, okay, is for entire network. All the systems will have the same public IP. But if you want, you can buy a unique public IP from ISP provider directly. Directly from ISP provider, you can buy a public IP address. So if you buy a public IP from ISP provider, what ISP will do is ISP provider will directly assign your network with a dedicated static public IP. So right now, the public IP which you are assigned with by ISP provider is not fixed IP. Okay. But if you buy a IP address from ISP provider, they'll charge you around 400 rupees per month. Okay. So you can call them and tell that you can purchase IP address every month around 390 rupees or 400 rupees. They'll provide you with IP address. So once they provide you with IP address, in your router, you need to configure it. Okay, in your router, you need to configure that public IP address. So what happens is, once you have a dedicated public IP, you can assign it to your system. So if you assign a public IP directly to your system, so your system will be globally accessible. How you are able to reach out to Facebook? When you type facebook.com, your request is going to Facebook's IP address. Okay. So how are you able to reach out to Facebook IP? Because Facebook has a dedicated public IP assigned to its server. Okay. That is why you are able to reach out to it. So it's very simple. My laptop is there. I can make my laptop globally accessible. Even my friend in US can access files which are there in my laptop. If at all I have a dedicated public IP only for my laptop. Is it clear? So if I want, what I can do is I can develop web applications and I can keep it in my laptop without using GoDaddy, Hostinger, all these kind of services. I can host my website globally without taking any services from any other clients. If I have my own public IP, that is enough. I can host my own web applications globally. I don't need any third-party services. Okay. Did you guys understand? So that means for your system, if you have a dedicated public IP, you can be globally accessible like Facebook or any other website. Okay. So similar fashion, what hacker will do is hacker will have his own dedicated public IP. So when he builds malicious applications or when he sends malicious links to you, his public IP will be attached to it. So when you click on that link or install cracked software, from your system, a connection request will go to the public IP address of hacker. Since he have a dedicated public IP to his laptop, he'll get your connection request where he can control your system. Understood? When online, did you guys understand? Yes. So I'll show you guys an idea I'll give you. Let's say, so I'm logging into my router. So this is my router. So I'm logging into my router. I have my own public IP address. Okay. So we pay for public IP. That is where we have hosted our VPN server and all. So this IP address which you see here is a dedicated IP address assigned to ER segment. Okay, our router. So if you see, usually I'll just give you guys an idea on how it works. Go to advanced. So the thing is, in your router by default, you will have dynamic connection, internet connection type for you guys. You'll have dynamic. But if you buy your own dedicated public IP in your router, you have to change your connection type as PPPoE, which the ISP provider will on call, he'll tell you, go to your router settings and you need to enable this PPPoE and you'll have this dedicated static public IP assigned. So the public IP which you see in your router, and if you go to Google and type my IP, you'll be seeing same. Okay, but normally, if you don't buy your own public IP, if you log in into your router, you'll find a different IP address. And when you go to Google and type my IP, you'll find different IP. Because ISP provider by default, they'll do something called CG natting. That's a different concept. If you want, you can do research. CG natting. Okay. So ISP providers will do this CG natting. So because of this, your router will have a different IP. And if you go to Google and type my IP, it will show different. It's called CG natting. Carrier grade NAT. So large scale network addresses translation used by internet service provider to share single public IP address among multiple subscribers. So the public IP which you guys will be assigned with is shared with other customers also. That means for your home network, whatever public IP you see, the same public IP might also be given to other providers as well, other subscribers as well. But if you pay them, they'll only provide that IP for you. So in that case, in your router, the IP which you see, and in Google, the IP which you see will be saved if you buy. So anyways, in router, we have a concept called natting. You can see NAT port forwarding. Port forwarding. So here we can add any private IP of ours, of our company's network range. We can keep any private IP, we can add. Here you see add option. So what happens is, for our systems, if you go to configurations and IP configurations, you can only assign private IP to yourself, not public IP. Okay. So since you can't directly assign your system with a public IP, what you are doing is you are binding one private IP with a dedicated public IP, and you are assigning that private IP to your system. So what will happen if you have, for example, 0.50 is an IP address which I'm using to bind it with public IP. So in my network, to any system, if I give this IP, that system will have a dedicated public IP. Are you guys getting it? So we can't assign our systems with a dedicated public IP. So what we do is we bind private IP with a public IP and we assign that private IP to our system. Okay. So how to assign in our systems with an IP address? So if you go to control panel, okay, and if you go to network and internet settings, go to network and sharing center and change adapter settings. So you'll find all the network adapters. So right now you are connected to Wi-Fi. So if you right click on Wi-Fi, click on properties, you'll find IPv4. If you double click on IPv4, you can see by default obtain IP address automatically. So what I can do, I can say use following IP. So I'll assign my system with 192.168.0.50. Okay. So this is the IP address which is binded with public IP. And subnet mask automatically it will fill. Default gateway means our router IP address. Right. So our router IP, let's go to command prompt. Type IP config. You can see our default gateway is 0.1. Okay. So I'll just go to 2.168.4.50 and default gateway. Google DNS server 8.8.8.8. Secondly is also 8.8.4.4. Google DNS server, if you just Google what is the IP address of Google DNS server, it will give you. Click OK. So what I am doing is I am assigning my system with a dedicated public IP. So if I say IP config, so I'll have 0.50 and I have default gateway and all is fine. So I'll have a dedicated public IP. Now, how will this be useful for me is, for example, guys, let's say I have some exam server, exam or Apache server, anything. So these are local softwares you can install. And if you see here, you can start your Apache service. You can start your MySQL. So if you have website in your system, it will be hosted. So now anyone who takes your public IP and types it in browser, and if they search in browser, so if you have website in your system, so since you started your exam server, that will be hosted. And since you have a dedicated public IP now, okay, so your website will be hosted. So I don't have any website though, but I'm just giving you an idea that in your system, you can keep any website and it will get hosted globally. Just by typing your public IP, anyone throughout globe can access your system, as in your files, like Facebook, how you are able to load the Facebook website. Similarly, they'll be able to load your website. Will you understand, everyone? But now what I can do is, if I'm creating any payload, I can use my public IP, attach it and send it to victim. If victim installs it, I'll be getting reverse connection because I have a dedicated public IP to my system. So I'm globally accessible. But the disadvantage is, if you make your system globally accessible, automatic web crawlers will be there. So they'll automatically crawl through your system. If you have your system has any misconfigurations, so you can be hacked. Okay, so it is a double-edged sword. So you'll use it for hacking, but obviously you are reachable globally. So even hackers can reach out to your system and hack it. And also default web crawlers will be there in internet. Whenever a system comes online as a public address, automatically they'll crawl through it. And if any misconfigurations are there, there is a possibility for your system to get compromised. So the thing is, this is a double-edged sword. It has a positive side and negative side both. But either way, I hope you guys have got an idea about public IP, private IP concept, and let me just change back. So anyways, in future, I'll show you about public IP, how we use it to create payloads and all. But if you guys ask me, sir, is this only way, like if I want to hack someone outside my network, do I need public IP for sure? Do I need to buy public IP? So there is an alternative called NGROC servers. NGROC. So NGROC port forwarding techniques we can enable. So we have servers like NGROC, which is for free. Okay, it's free. So what happens is you can run this NGROC in your system. So what NGROC will do is NGROC is a server which is globally accessible. So NGROC will provide you with an IP address. With an address it provides you. So you can use that address, create payload and send it to victim. So when victim installs it, from victim system, the connection request first goes to NGROC. From NGROC, it will come to you. So NGROC will act like a mediator for you between you and victim. Okay, between hacker and victim, NGROC will act like a mediator. It's called NGROC port forwarding technique. So without having your own public IP, still you can hack anything outside your network using NGROC, which is a free service. But recommended is having your own IP. It's more reliable. But we also have alternative, that is NGROC port forwarding technique to compromise devices outside network. All right. Got it, guys, so far about IP addresses. So we have seen public IP, private IP. Static means fixed IP. Dynamic means temporary IP. So the IP address which we are assigned, public or private, are by default dynamic. Okay. If you want private IP, you can assign yourself with static for free. But public IP, if you want to assign yourself with static IP, you have to buy it from ISP. Okay. So that is the difference between these IP addresses. Okay. So I hope this is clear so far. Now moving forward, in IP addresses, if you remember, I told you we have different classes of IP. Classes of IP. So what is the class of IP and how is it important for us? We'll see here. So if you guys see in here, we have different classes of IP. You can see it starts off with class A, 0 to 127 is class A. Okay. And then class B, you have 128 to 191, class B. From class C, 192 to 223. Class D is 250, 224 to 239. And class E is 240 to 255. So if you see in this entire IP, can you see any number which crosses 255? At maximum, even subnet masking also, you see 255 is max. Why 255? How did we come up with 255? So the 255 concept I'll tell you. So What is the size of our IP address, guys? 32. So 32 bits. So in our IP address, we are having like this, right? 192.168, some 0.1 or something like that. We have this. So in this IP address, we are mainly having an IPs. We have 4 octals. Octal 1, octal 2, octal 3, octal 4. Octal means 8. Okay. So it is octal 1, octal 2, octal 3, and 4. Each octal is 8 bits. So 8 plus 8 plus 8 is 8 plus 8 plus 8 plus 8 is 32. So the size of IP address is 32 bits. Till here it's fine. So the size of IP address is 32 and we have 4 octals in IP. Each octal is 8 bits. So 8 plus 8 plus 8 plus 8 is 32. Now, since we have 8 bits, let's consider these 8 bits. So if you see, it starts from 2 power 0, 2 power 1, third bit 2 power 2, fourth 2 power 3, 2 power 4, 2 power 5, 6, and finally 7. Total 8 bits are done. So 2 power 0, 2 power 1, 2 power 2, 3, 4, 5, 6, 7. Okay, so 2 power 0 is 1, 2 power 2, so 4, 8, 32, 16, 32, 64, 128. Okay, so now if you see how the transmissions happens, it's basically on and off. Power pulses will go on, off. Yeah. So the thing is, if all 8 bits are on, you can add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. If you add it, you will get 255. Are you guys getting? So maximum you can turn on is 8 bits. So if you switch on all 8 bits, it will be 255. Okay, that is why in IP addresses you see in octal 255 is max. You can't go beyond 255. Got it? So that is why you only see 255 max. Even in subnet mask or even in IP range, maximum it goes is 255. That means all 8 bits are switched on. So, for example, let's say I want 240. I want 240. So out of these 8 bits, how many bits should I switch off in order to get 240? 128 plus 64 plus 32 plus 16 is 240. So I need to switch on these 4 bits in order to get 240. Remaining 4 bits should be switched off. Okay, so that is how if you see the numbers in here, in background, if you are seeing 127 or 191 or 223, so basically we are switching off certain bits in those 8 bits. We are switching off certain bits in order to get that number. Okay, so if you see, when it comes to class A, 0 to 127 is the range for class A. Okay, so in class A, if you guys see, 2 power 24 possibilities are there. 2 power 24 means 16 million possible hosts can be created, or 16 million possible IP addresses can be created in class A. When it comes to class B, 128 to 191, it is 2 power 16. So in here, we can create 65,536 possible IP addresses. In class B, we can create 65,536 possible IP addresses. In class C, we can create 2 power 8. 2 power 8. So 2 power 8 means 256. So 256 possible hosts can be created in in class C. Okay. So how are we getting this 16 million or so? So if you see the subnet mask of class A, you are able to see how many bits are on. 4. 8 bits are on. How many are off? 8 plus 8 plus 8. That is 24. So 2 power 24 possibilities are there. In class B, in subnet, how many are off? 16. So 2 power 16 are there. Class C, 8 are off. 2 power 8 possibilities are there. Did you understand the subnet? So if you see subnet, you can understand how many bits are off in the network. Okay. So the more number of bits are switched off, the network size is that much big. Okay. The more bits are off, the size of the network increases. Yeah. So I'll also show you the calculation and all. But for now, I hope you guys have gotten some idea. But why only till class C you are able to see? What about D? What about class D and class E? This is for research and development purpose. Only in defense, government, they use it, not for normal other people. So we use class A, B, and C in companies, and in as an individual person also we use the same IPs. So normally the thing is, in normal household, we will not have hundreds of systems. So by default, we'll be having class C. In small companies, medium companies who have less than 256 devices, class C. If you have more than 256, you can go for class B range. So class B is 202 power 16, that is 65,536 possibilities. If you have more than 65,000, go for class A like Google and all. So big organizations, they can go for class A, which is 2 power 25, 16 million hosts. Yeah. So if you see the range of IPs, so by default in your home or in small companies or medium scale companies, we'll see in 192 series range. Okay. Again, in this, I'll tell you the division for private range and public range. But for now, understand class C we use. Okay. Class B, large scale companies use. Class A, it's used by very big organizations. Okay. So depending on the size of the organization, they can use that particular range of number. Now, what is this -2 for all? So in every network, guys, 2 IP addresses are fixed. Network ID and broadcast ID. These 2 are fixed IDs. So that is why if let's say size of network is actually 256, but possible number of hosts are -2, that is 254 possible hosts are there. Okay, because 2 IPs are fixed, 254 possible hosts can be there in the network. Okay, so that is why we will see -2 number of hosts per network. Okay, clear so far? So now let's get into the subnet masking. So when we are assigning ourselves with IP addresses, or when we check our own IP address also, we are able to see the subnet mask. As I told you, it's very simple. So when you are in class C, you'll have the subnet mask. Okay. So if you see in subnet mask, if you see first three octals are maxed out, 255 is max. So if first three octals are maxed out in your IP address, first three octals are fixed IPs. Okay, those are network ID. So in your subnet mask, if first three octals are maxed out, in your IP address, first three octals are network ID. That means it's fixed. For entire network, you'll have the same first three octals. Last octal is not maxed out. So in your IP address, last octal is called host ID. It varies. Okay. So if you have, for example, your subnet mask is 255.255.0.0. In that case, in your IP address, only first two octals are fixed. Remaining two are host ID. That means it can vary from 0 to 254. It can vary. Okay. So let's see the calculation. Before that, I'll also show you guys private IP and public IP. Again, in our IP addresses, as I told, so we have different ranges. Okay, public and private IP range. So it might be little blurry, but you guys can see here. It starts with 10 series, class A, private IP range, 10.0.0.0 to 10.255.255.255 is for class A. Class B is 172 series. 172.16.0.0 to 172.31.255.255. So that means if you see class A starts with 10.0.0.0 to 10.255.255.255, right? So that means your IP can be 10.0.0.1, 10.0.0.2 till 10.0.0.255. Again 10.1.0.0, 10.2.0.0, 10.3.0.0. Like that, you can see the probability and combinations. Okay, that is why it can create 16 million possible IPs. Okay, but either way, if you see, it starts with 10 to 10.255, 255, 250. Similarly, when it comes to 172, class B, it starts with 172.16 and .0.0 to 172.31. That means you'll not find private IPs like 172.32 because till 31 only we have. Or you'll not find 172.15 because it starts from 16. So second octal in class B from 16 to 31 you have. Okay, private IP. That means mostly in your colleges and all, you'll have multiple blocks, multiple systems, more than 256 devices. So obviously in your colleges or offices, medium scale companies, you'll have 172 series private IP. So if you have ever checked in your college labs and all, your IP address will be in 172 series. And then class C is normal individuals or small companies. you will have 192 series. 192.168.0.02, 192.168.255.2. So we have this 192.168 fixed. In your home, you might have 192.168.10. Here in our office, we have 192.168. These two are fixed for both of us. But the third octal, in my network, it is 0. In your network, it might also be 0, or it might be 1, it might be 2, it might be anything. Okay. But in your network, if this third octal is 1, for all the devices connected to your Wi-Fi will be having 1. Yeah. All right. So this is our private IP range. Remaining all are public IP ranges. Remaining all are public IP. So if you want to assign yourself with an IP address, so if you are in class C, you can only assign 192 series. If you are in class B, you can assign 172 series. Class A, you can assign 10 series. But when you're configuring, let's say you're not connected to router, it's not mandatory that for your systems you have to give only class C IP. If you want, you can also give class B IP or class A IP also, 10 series or 172 series also you can give. Okay, if you are manually assigning your system, you are not interacting outside network. So manually, when you are assigning your systems in Cisco Packet Tracer or your own machine also, so only switch you will be connected. So in that case, you can assign 172 series or 10 series IPs also. Okay. No authorization required for it. It's not that you have to only assign 192, nothing like that. Which one? Class C. Class C third octal till 255. 0 to 255. Anything between. Only in class B, you have a unique condition where the second octal is 16 to 32. But remaining all 0 to 255 only. All right. So guys, this is our private and public IP ranges. Okay. Now the thing is, getting back to our subnet masking. Okay. So we already understood how subnet masking works and all. So all 8 bits, if you have subnet mask like 255, 255.255.0, so that means you can clearly understand that 8 octals are switched off. So 2 power 8. So it's an easy scenario. So now the thing is, let's say if a client comes to us, okay, and they tell us that they want network security to be done on their company. So what they'll do is they'll give us CIDR notation. CIDR. CIDR means classless identifier. So CIDR notation they'll give us. So it's very easy to calculate CIDR. From CIDR, you can ultimately decode subnet masking, or from subnet masking you can decode CIDR notation as well. So how is it calculated? I'll tell. So for example, a client approached us. They'll not tell us that in their company they have 100 systems or 200 systems or 1,000 systems. They'll not tell that. They'll say that their network, their CIDR notation of their network is, let's say, /24. /24. Or they'll say /16. Or they'll say /8. Okay. or they'll say /30. Anything. So if they say their CIDR notation is /24, that means you need to understand that in their subnet, 24 bits are on, 8 are off. So 24 bits are on means out of 32, 24 are on, 8 are off. So CIDR notation means it will tell you how many bits are on. So 24 bits are on means 8 are off. So that means their subnet mask will be 255, 255, 255.0. If they say that there are /16, that means 16 bits are on. So 32 minus 16 is 16 are off. So if 16 bits are off, the subnet would be 255.255.0.0. If at all they reach out to us and they'll tell us that, okay, their subnet mask is, their CIDR notation is 8. That means 24 bits are off. So their subnet will be 255.0.0.0. Yeah. And let's say /30 or /28, if they say. So it's very simple in this case. So how many bits are off? So 32 minus 30. So it is 2 bits. Okay, so 2 bits are off. So in that case, what will be the subnet? In this case, 4 bits are off. Okay, I'll tell you. If you are connected your mobile hotspot to your system, so you know your subnet mask will be 255.255.255.240. This will be your subnet. So 240 means how many bits are off? 4 bits are off. To get 240, 4 bits are off. You can calculate. Just now we have seen that calculation. So 240 means 4 bits if you on, it is 240. So if you switch on 6 bits, okay, so that means 240 plus 8 is 248 plus 4 is 252. So if your subnet mask is 255, 255, 255, 255.252, your CIDR notation is /30. If it is /32, only one system is there because all bits are on. Okay, 0 bits are off. So 2 power 0. So one system only. So like that, basically with CIDR notation, you can derive subnet masking, or from subnet mask, you can derive CIDR notation, either way. Clear? So with subnet mask, we can easily understand what is the size of their network. Okay, in subnet mask, again, as I told you, if you have 255 maxed out, that means in IP address also first 3 octals will be fixed. If first 2 octals are 255 in subnet mask, in IP also first 2 will be fixed. If only 1 octal is 255, in IP also 1 will be fixed, first octal. So like that, this works. Clear, everyone, so far? Understood how this works? IP address, subnet masking. So you can assign yourself with your own private IP. We have assigned initially, right? So you can assign private IP. Subnet mask automatically it will take, because when you get private IP, if it in class C, automatically class C subnet mask it will take. So for class A, first octal is network ID, remaining 3 are host ID. Network ID means it is same for entire network. In class B, First two are network ID and last two are host ID will vary. In class C, first three are network ID and last one is host ID. Yeah. So that means if you are in class C, okay, let's say I'm a hacker, I entered inside a network and when I check my own IP, it is in class C. That means if I want IP addresses of my victims, I'll not go to each system and check their IP. So if I check my own IP, I already know first three octals of my victims. Only thing I have to find is what is their last octal. So last octal can vary from 1 to 254. Okay, because 256 minus 2, 254. All right, everyone. Yes. Any queries still here about IP addresses, subnet masking? So in order to identify IP addresses, basically the thing is we have, normally we have a, let's say as an attacker, I want to identify some, uh, like what is my network, what is the IP addresses of other systems. Usually the thing is if I send a ping request to each and every system, 192.168. Let's say my IP is 0.50. So my victim IP is this, first three octals are fixed. Last octal can be 1. I'll send a ping request to 1. If there is any system with this IP, it will respond back. You'll get reply. Okay. So similarly, I'll go for .2. If there is no system with this IP alive, so it will say destination host unreachable. So like that .3, .4, .5, I have to go individually. But that is time taking process. I have to send for 250 for possible IPs. Okay, practically it's not correct to send ping request to individual. So in Kali Linux, we have tools like Nmap. So using which we can just directly give range of IP. Within seconds to all the IPs, automatically it will send ping request. And whichever IPs are alive, it will give us 4 systems are alive in network and these are the IPs. So in future, we have in ethical hacking, we have network scanning module. Scanning, we have module in which you will see network scanning, network security, scanning networks, identifying operating systems of each IP address, okay, finding out open services, exploiting them, all those things in ethical hacking we will see. Okay. So this is about our IPs and subnet masking, guys. So for today, I'll stop till here. So you guys have to do research on what is IP addresses, subnet masking calculations, assign yourself your system with your own private IP address. So check your router IP range, check your network ID of router, and then assign yourself with a static private IP. Okay, to configure your IP address in your system, not router. First, yeah, Wi-Fi will have a separate IP, private IP. Every network device in your network will have a separate private IPs. So your router is there, means router will have a private IP, your laptop will have a private IP. But since your router and laptop is connected to same network, so you both will have same network IP. So if you see my laptop has 192.168.0, even my router has 192.168.0. Okay. So when you are assigning yourself with an IP, so check your router IP. And if your router IP, let's say the third octal is 0, so you have to assign the same network IP statically. while you are assigning it to your system. So this will be it for today, guys. So make sure that last task which I have given, Cisco packet tracer, topologies, and connecting two networks together with a router and communicating. So you complete those tasks, and today IP addresses concepts complete. Get this weekend. Next session will continue. Probably I'll tell you about enterprise architecture. On Monday or Tuesday, I'll take up the enterprise architecture. In companies, what is the hierarchy? So where switch comes into picture, where router comes into picture, where firewall comes into picture, servers comes into picture. So how do we set up in our organizations? So we'll take that session either on Monday or Tuesday. So complete the tasks and update you. One session on. All right, guys. So this will be it for today. So we'll catch up on Monday again. Thank you all. Thank you so much. If you have any queries, you guys can ask. Otherwise, we can catch up on Monday. Thank you all. Thank you so much. Have a nice day, everyone.